All right, so this is more about some of the C function we just talked about a little bit ago, or C is part of the function. And we're going to look at general and specific antiderivatives. So if we have a function f again, and it's in terms of x, and c, which is an arbitrary constant, then if we take the integral of f of x dx is equal to f of x plus c, that's called a general antiderivative of f. So the general one is when we just have c. But we have a specific one when the constant c is known. So f of x plus c is, c known, maybe that's plus 8. That's a specific antiderivative. So that's the difference between general, which we just keep the c, and specific, where we actually have some number known. Now, the integral sign has no upper and lower limits for general antiderivative notation. As you notice here, it's just the integral of f of x dx, and we don't have it from a to b or anything else. And the dx in this notation is to basically remind us that we're finding the general antiderivative with respect to x here, okay? And so the antiderivative formula will be in terms of x. So we'll have, when we're going from the integral of f of x dx, little f, then we're going to get a capital F of x out plus our c. And then if we don't know what c is, it's a general. If we can calculate the c, then it's going to be a specific antiderivative. All right, so how do we find these antiderivatives? Well, let's start with taking derivatives. So the simple power rule for derivatives is written as d dx of x to the n. And when we do that, basically we're going to bring down our n to the front, subtract 1 here, and we're going to get n x to the n as our derivative. Well, how do we do that? Well, we multiply by the power n, so we multiply out front by that power n, and we subtract 1 from the power to get n minus 1. So that's how we do derivatives. We've done that. Not too bad. Now, we reverse that to find antiderivatives. So what we're going to do is we're going to add 1 to the power to get the new power, which is going to be now n plus 1. And we're going to divide by that new power of n plus 1. And then we're going to add the constant of integration, which is plus c. So simple power rule for antiderivatives, x to the n dx, take the integral of that. We're going to get x to the n plus 1 over n plus 1 plus c. Now notice n cannot equal -1. That's going to be the whole key. If n is -1, we're actually going to get a different kind of value. We're going to get things with ln's and stuff. So we won't worry about the -1 yet. That'll come in a little bit. So if we want to take a general antiderivative of f of x is equal to x squared, what do we get? Well, it's going to be the integral from x, or integral of x squared dx is going to be, well, we're going to add 1 to this, so it's going to be x to the 2 plus 1. And now we divide by that 2 plus 1, and we add c. So we have those 3 parts. We have to add 1 here, divide by that exponent, the 2 plus 1, and then add the c, and then we simplify. So that's just x cubed over 3 plus c. So that's just our general antiderivative. Now, if they had given us some more values, then we could actually calculate the c and we could find the specific, but they just said to find the general. All right, so let's pause there and we'll come back for more.